help support our coverage using Blueberry, the community that gives creators the ability to make money, get detailed audience measurements, and host their audio and video. Get 30 days to try out the service using promo code Blueberry004. That's BLUBRRY004.
Well, we have our next guest here. Hello.
Hi there.
How are you doing today?
I'm doing great.
Go ahead and introduce yourself for me.
Okay, so my name is Paul Tartaglia. The company I'm here representing today is Delvitech. It's a Swiss-based company. I am the U.S. head of operations.
I figured you weren't Swiss.
Not Swiss.
Okay.
I'm here as part of their delegation, and Delvitech is a new company. It's a relatively emerging startup, and we're here demonstrating technology. The application of artificial intelligence in optical inspection.
Okay.
So it's not what I would consider the typical product that you may be seeing here at the CES show with regards to an actual consumer, a business-to-consumer product. We're a business-to-business product, but our product...
You're one step away.
We're one step away from the standpoint that everybody out here that's making electronics produces printed circuit boards,
sure,
right, to go in their product.
Yeah.
And our product
We've got them in light bulbs these days. Yeah.
Correct. And so our product is used in the manufacturing process of all the electronics.
Okay.
And what we're here as part of the Swiss delegation is to introduce the product. The Swiss are very interested in promoting companies within Switzerland that are bringing in new technologies, right, and that's where we think we fit. I mean, this is it's a mature industry, and there are many competitors, and they do things a certain way as they've been doing for decades.
Sure.
We have a new technology based on AI that we feel can be disruptive, and we're trying to get our name out. We're trying to get established and this type of thing. So that's kind of what we're here for.
Okay. And I'm reading over here. So are you looking for errors in production? Verifying success production?
Correct. This is part of what the product does. So typically optical inspection, and this can be with any industry. We particularly have focused in electronic manufacturing because that's where our founders' experience is, and
sure,
many of us that work there have that same type of experience.
Okay.
So in any type of manufacturing process, there's always a quality assurance process. And so when the process has multiple things in the process, like it does in printed circuit boards, many of the steps have to be inspected to ensure that they meet what the engineers have as a standard, whether it be a solder paste or component placement or after reflow, all these, hopefully not too many technical buzzwords there. But right now, they have specific optical inspection equipment after each one of these processes, right? So a different machine after this process, a different machine after this process, a different type of inspection here. Now, with our technology, we can inspect any of these parts of the process with the same machine. So from a scalability standpoint, now a company, instead of having to buy maybe 2 or 3 different machines from different vendors
and dial them in for different steps and
correct.
Okay.
Correct. So now we have one that can be adapted to each one of those processes. So from a company standpoint, if you're building a product, the scalability and the fact that you could use one machine across 3 different applications in the factory will, of course, be easier training for your engineers, less spare parts, maintenance, and. And then, of course, if you're a multi-line manufacturer,
if you're Foxconn,
then of course all this information that Foxconn, right? So they have hundreds of these machines.
It's the big manufacturer that everybody knows.
Correct. So Foxconn uses these machines, as do all their competitors, and really anybody in the space of electronic manufacturing these days has to have this. You have to ensure that the product that's going at the end of the line is quality, right? And currently most machines are being utilized only as a pass-fail. So it comes in, it takes a look at the board, takes a picture, compares it, and if it passes, it goes to the next part. If it's an error, it gets kicked out. And this is where we hope to come in with the AI, because with the AI, during this process, we can learn every board that comes through. We grab all the data, right? And so as the machine continues to process, we're able to look at the process and how it could drift from a process monitoring standpoint, and then if we see a trend developing, we can feed this back to engineering and possibly catch an error prior to it happening, which means we save a board from being scrapped or wasted or reworked. And this is big money when you're talking high volume applications like a cell phone or some medical devices, whatever. Right?
Yeah. So, like, it would be able to look at trends and see it happens frequently between 2 and 3 p.m.
That's possible. Typically on a manufacturing line, you see parts of the process start to drift because of other influences. Say, for instance,
I was thinking humidity.
Humidity is one because you have a process where they actually bring a board into an oven. So it's an oven, and this is where the solder gets reflowed onto a part, right? And it's temperature dependent. Humidity is a part of that, as part of the process. All this is defined when they do a new product introduction or a prototype, right? So they set up like a golden process. This would be the perfect process, and we get a perfect board.
Yeah.
And then everything that comes off is kind of judged against that standard, and there's tolerances built in of what's acceptable and what's not. So between the acceptable, perfect part of the process and what is at the bottom scale, if it goes below that, we have to reject it. There's things that happen that the machine could catch through inspection and then feed this back. Maybe the temperature is starting to get too low or too high. You can adjust that before you get a failure.
Okay, gotcha. And how detailed is this for our viewers that have been around for a while? There's a particular product that they're aware of that there was a huge failure on. That we kind of became the face of accidentally. There was a manufacturing problem that we discovered.
Okay.
That made it out of the factory.
Okay.
And into Walmart.
Okay.
And they claimed, I wasn't in the factory in China, they claimed to have this process in place, and yet this got through.
Yeah.
So how detailed is the...
So it's all very detailed,
here,
but you still have a human factor because this is part of the problem we're trying to overcome. With the current generations of machines, typically they're implemented as a go and no-go, right?
Right.
Okay, it passed, it fails, it passed, it fails, and there's not really any data collected, anything done with the data that would affect a process monitoring, right?
Okay.
Okay, so if you're in a high-volume manufacturing scenario and you get false errors, which this is one of the main problems with the machines. If you have a false error, which means that the machine says the board's bad, but then when someone pulls it off and looks at it, it's actually good.
It's fine.
Okay, then you got to put it back in process. If you get too many of these things and you have an expectation to get X amount of product per day out the door, they just turn the machine off and they pass through. So they may do it. They may do it. They may do test every hour, or they may run it every 100 or so boards, but they possibly don't do 100% inspection.
Sure.
And that's how something like that can get out, because it's the inspection process is affecting other parts of the process that affect the bottom line, and so people don't use it. So what we're trying to do, again, is make it where it's utilized on every board, learn from every board that we take an image of using the AI and develop this whole thing, right?
And so if it scans the thing, it's a false negative. It comes out, a person says, nope, fine.
Correct.
It can be marked as such and learn from its own mistake.
Well, what we do is we don't actually do that. I mean, it's how can I explain this in something that's not super technical? I mean, you can actually do that. I guess there's always a chance we could get a false negative, and it would be treated the same way anything else is, right? So you pull it out, you look at it, an engineer is going to determine if that was actually a defect or not, right?
But can the AI then learn?
We can
from
learn
that?
this, yes.
Okay.
So we can say this is a good product, and for what it'll tell us why it thinks it was bad, right? So we're not going to just randomly inspect. We're going to go to the particular part or whatever's the failure mode on there and see if that is correct or not, okay? And then we can teach the machine, it can learn that next time it sees this, it's not going to be an error.
Right.
Okay.
Gotcha. Perfect.
And again, this is how it builds up the data to make the process much more sustainable.
Yeah.
And then again, as we start to see these trends, as it catches these things and it's okay, it builds its own internal intelligence so that when it recognizes these things, the next time it sees this similar occurrence, it's going to say, this is a good board, I've learned this, and away we go.
Very cool. This already exists?
Yes. Yes. Now,
Out in the wild, manufacturers can use it, or are we
well,
there yet?
this is the problem. So the problem with electronic manufacturing is that we've had automated equipment for decades, right? So we have machines that do things automatically. But the connectivity between the machines to do things automatically is still growing. And so I would say it's still in process because there's a whole different level of connectivity that has to happen on a manufacturing floor, machine-to-machine communication that would take the information our machine is able to develop and that data, and then it's got to be translated or moved to a machine from a different vendor, right? So we have to have a communication protocol. The industry is working on that right now to try to get to the point where the communication from some of these quality devices can feed back into the actual machines that actually do part placement or solder screen printing, these type of machines, and then give this information back to them to make adjustments that could correct an error. But that's still in the works.
Gotcha.
But the first start is we have to do our own thing and generate the data, collect the data, and then make it useful for the end user.
Gotcha.
Okay.
For companies that might want to follow your journey and find out when this is ready for prime time, how can they do that?
Well, we have like everybody else, a website, delvitech.com, delvitech.com. It's probably the easiest way. We're on LinkedIn. We're on your podcast now, right? So we're, again, at the show here trying to get the message out of who we are, that we do exist, that we do have this technology. Also, anybody could contact the Swiss Tech Pavilion, the people that set up the whole interface between the Swiss companies and these shows could find out more about us there.
Very cool.
All right.
Well, thank you for coming and talking to me.
Appreciate the opportunity.
Yeah, for sure.
Thank you.
Have a good one.
Thank you.
The Tech Podcast Network CES 2024 coverage is executive produced by Michelle Mendez. Technical directors are Kurt Corliss and Adam Barker. Associate producers are Nancy Ertz, Clinton Millsap, Sergio Velasquez, and Terry Willingham. Voiceover by Aaron Hurst. Our hosts are Marlo Anderson, Don Bain, Todd Cochran, Scott Ertz, and Christopher Jordan. Studio and equipment are provided by PLUGHITZ Productions. This has been a Tech Podcast Network broadcast, copyright 2024.